Okay, let's see if you guys can do this Venn diagram problem. Let's say this diagram here represents everyone in your class. There are 32 people. All these people here takes biology. All these people here takes physics. And all these people here takes chemistry. And there are 4 people who don't take physics, biology, or chemistry. Now, if I were to pick out 2 people at random, okay, pick out 2 people at random from this class, what is the probability that at least one student will take biology and physics, will take both biology and physics, but not chemistry? Okay, I know this question is a bit long and convoluted. You just got to spend some time to try and understand the question. So let me start again. I'm picking out 2 people, two students from your class. Now, I only require one student to, well, at least one means I only require one student taking, taking both, both biology and physics, but not chemistry. Now, you've got to, learn to break up the question. So both biology and physics, what does that mean? Both biology and physics means all these people here, but not chemistry. Well, not chemistry. So you've got to delete the chemistry part. So basically, people, you want students coming from this segment here. Okay. Now, and then you have to jump to the first part of the question, which is saying at least one of the 2 students. So remember, I'm picking out 2 students. So at least one student would, well, it would mean this. You've got to draw your tree diagram. So this is good. Let's say this is, let's say, hang on, let's say this would be good. Okay, good, and this would be bad. So a good student here. Let's say a probability of you picking out another good student, bad student. Remember, we're picking out 2 students. We just want to know the probability that at least one of the 2 students, at least one. So if you have 2 students so if you have 2 students, that would be a good outcome because it's at least one. Okay, so at least one. Well, if you draw your tree diagram, good, bad here, you see good, good. That means 2 students are good, so that would be a good outcome. A good student, a bad student. Well, that would be a good outcome because it's saying at least one. Okay, and here, well, this a bad, good. This would be a good outcome. Well, this would be a bad outcome. Okay, so you just got to learn to break up the question and try and understand it bit by bit, taking both biology and physics, but not chemistry. Well, you know it's going to be this part, and then you've got to combine the Venn diagram with the tree diagram in order to answer this question. So press pause and have a go. Okay, answer this question. Press pause and have a go. Okay, so both biology and physics means this. Both biology and physics means this. Okay, but not chemistry means, well, we've got to remove the chemistry part. So we are only interested in, this, this, and this. Okay. Now we are picking out 2 students. So jump to the tree diagram. Let's draw it like this. So let's say this is a good student, this is a bad student. Probability of us picking well, we're going to define good students as students taking both biology and physics, but not chemistry. Okay, so the probability of us picking a good student would be well, this, and this. So that would be 10 over 32. The probability of us picking a bad student would be, hang on, let me change, that's the 10. Okay, probability of us picking a bad student would be 22 out of 32. So okay, let's go back to the beginning of time. We've just picked out a good student, so we've gone down this path. What is the probability of me picking another good student? Well, another good student would be 9 out of 31. Okay, a probability of us picking a bad student would be 22 out of 31. Okay, let's go back to the beginning of time. we're going to pick out one student. Probability of us picking out a bad student is 22 over 32. The probability of us picking another bad student would be 21 out of 31. Okay. Now, if we've gone down this route here, the probability of us picking a good student would be 10 over 31. Okay. So probability of good. Well, this is a good outcome because it's saying at least one student. So good student. If you have good here and bad student here, this is also a good outcome. Well, a bad student, a good student, this is a good outcome because it's saying at least one student, at least one. Okay. Well, well, this would be a bad outcome because we need at least one student. Okay. So we are interested in this branch, and this branch here. So hang on. So we are interested in probability of, let's say, good equals, well, we need this and this. So we need 10 over 32 times 9 over 31. Okay, and then the second branch which we're interested in would be good and bad. So good and bad. Oh, bad. So that would be this branch here, this one and then this one. So we need this and this. So it will be 10 over 32 times 20 times this here, 22 over 31, 22 over 31, and then the last branch, which is this one here, we are bad and good. Okay, so probability of bad and good would be, well, we need this times this. Okay, 22 over 32, 22 over 32 times this here, 10 over 31, 10 over 31. Okay, so now, hang on. So top times top, that would be 90 over, calculator, hang on, calculator. We need 32 times 31 equals. So here, bottom times bottom would be 992, I think. Let me double check. Yeah. And then here, top times top, this would be 220 over 992, and then top times top here would be 220 over the same thing, 992. So the probability, so to answer this question here, probability at least one student taking both biology and physics but not chemistry equals all these three added together. So you need to get this, add this, add this. Okay, so that will be, well, let's add them all together. So it will be, hang on, the top, well, so get 90, we're going to get this, add this. So, hang on, we're going to add 220 plus 220, that becomes 440, and then add 90. So now we're going to add 90. So basically, I'm just adding the three numerators together. So this will be 3, 1 would be 5. So 530 over 992. So this will be your answer. So basically, this here is just basically all these three added together. Okay. So this here would be our answer. But it's a bit hard to picture what's going on here. So convert it to a decimal. So calculator, convert. So get 530 divided by 992 equals 253. Now let me double check. Yeah. So the probability is 0.53, or you can say 53%. Okay. Well, because you're interested in 3 branches here, it would be easier just to get this times this. Just work out this branch here and get 1 take away this branch here. So a quick way of doing it is to get 1 take away. Well, work out this branch here. Just get 1 take away this thing here. So for example, we would get to the same answer here. Just work out. So our answer could be 1 take away probability of bad. Okay, so this would be 1 take away. What's the probability of bad? Well, bad would be this and this. So we need to times the 2. Okay, so we need to times the 2. So it will be what is it? 22 over 32. Let me double check. 20. So we need this times this here. I'm just showing you another way of doing it. So this one here, 31. So 1 take away. Now jump to the answer. Jump to a calculator. Clear this. 22 times 21 equals this. Equals 462 over 32 times 31. 32 times 31 equals 992. Well, now you can just get 1 take away this. What I'm trying to say is, instead of working out 3 branches and adding them together, you can just work out 1 branch and then just get 1 take away this branch here. That would be the same as you working out 3 branches. Okay? Well, the answer to the question is this here, 0.53. Okay?